And so, guys, no, welcome sa ating discussion. We will continue our discussion here in fluid mechanics. So, last time, we've discussed about yung ating mga plane surfaces, yung mga nakasubmerged, no, or yung hydrostatic forces sa plane surfaces. And we also approach, no, yung iba't iba, may tayong geometric, may formula method. So, today, we're going to continue our discussion on that, no, sa ating mga hydrostatic forces. But this time, what we're going to discuss is the hydrostatic force on inclined, no, plane, kasi last time mapapansin nyo oriented siya as 90 degrees or 180 degrees, hindi siya naka-incline, no? So, or curved surface. So, ito yung discussion natin for today. To start our discussion, let's first have this illustration. So, na illustration na to, napapansin nyo, ayan, so meron tayo ditong curved surface, ayan, so ito yon or inclined, no? So, pwede din siya naka-incline, no? Incline lang yan, naka-flat, no? Ito yung ating liquid na naka-submerge, no? So, ayan, mapapansin natin na meron tayong normal pressure na nag-a-act dun sa ating submerged surface. So, usually, naka-incline nga siya kasi meron ditong angle of inclination. So, ayan po yun, no? So, force na to also, no? Kapag naka-act siya no normal, usually meron tayo tatawag na normal force o yung resultant force natin na nakikita natin ito yung F sub R. We also, in this illustration, we're going to have a small part ng ating area, no, which is we call D sub A, dA, no, and also yung small part ng force, no, yung resultant force galing sa variation nitong pressure na to kasi nga hindi naman sila pantay-pantay, di ba? So dF. Okay, to further discuss on that, no, let's focus on this one. So galing to dito, no, sa nauna. Sige, balik natin. Ito yan. Ito po yan, no, ito yung portion na yan. Makikita niyo. Then kinuha natin yung element na yon, ito na siya ngayon. Okay? So, ayan po yon yung D sub A, just like I've said, no, kukuha lang tayo ng portion doon. So, ito po yon, no, ito yung kanyang, ngayon kung naka-incline siya, D sub A. Pag hindi natin siya in-incline or ginawa natin siya naka 180 degrees or with respect to a certain axis, in this case, let's call it x-axis, it will be dA cosine theta. O tinatawag natin horizontal projected area. Ngayon naman, pag ginawa natin siyang with respect to, let's say, y-axis or nakatayo naman, it's dA sine theta. Okay? So, it also follows the same thing when it comes to our forces. Kanina, sinabi ko, nakukunin lang natin yung portion ng force o yung dF ng total na resultant force kasi varying yung ating pressure. Okay? So, ayan po yung sa dF. Yung ating dF, no, from the formula pressure, no, that is pressure multiplied by the area. But in this case, ang tinitingnan natin is yung dA, yung kinuha lang natin element from that submerged surface na naka-incline kasi meron siyang angle of inclination. So, from this element, hindi natin makuha yung ating mga component forces. First, we have yung tinatawag natin horizontal component. Ngayon, paano nga ba natin makukuha or how are we going to calculate or to analyze for the horizontal component of force na isang submerged or curved surface. So, ito po yan, no? So, ito yung mga illustration, pero ito yung kanyang meaning. Let's read this, no? The resultant horizontal force component acting on the plate or on a plane na nakasubmerged or curved, okay, ay equal to the resultant force of the pressure loading acting on the area of the vertical projection plate. So, yung kanina, no, balikan natin station, ito napapansin nyo sa inyong left side na inyong screen. So, ayan po, no? So, ito yung sinasabi doon, no? Yung ating nag-action ng normal or nagpo-project siya dun sa vertical projected area. Ito po yun. Kaya, from there, okay, makuha natin na yung pressure, no? Ito sa ating, or should I say, yung force, horizontal component ng force, ay manggagaling doon sa pressure na in-apply multiplied by the vertical projected area, which is sine theta dA, or ito galing, no, dA sine theta. Therefore, no, galing doon sa concept na yon, you will have this formula na nasa baba na inyong screen na nakikita ninyo, which is F sub H, no, force or horizontal component of force is equal to the integral. Kasi nga, kumuha tayo ng component maliit lang na portion, okay? Ng P sine theta dA, which is yung ating limits is from the area ng ating ina-analyze na element. Okay? Sabihin, kung vary yung area, just like yung una illustration, from A sub 0, or A sub 1 to A sub, parang ganon. Okay? So, ganon yung ating analysis. So, in this case, napapansin niyo A lang nilagay kasi nga, rin na magiging meron siyang known, magkakaroon ng known area. Okay, so ayan po yung ating horizontal component ng force when it comes to yung ating submerged or plane surface. Okay, ngayon naman, how about this one? Okay, ito naman, from this illustration, mapapansin natin, no, ito yun, di ba? Ito yung F sub H, yung kanina in-analyze natin. Ayan, so, naka-project nga siya dun sa ating vertical projected area, di ba? Nabanggit natin kanina ito, yung sine theta dA or dA sine theta from the illustration, previous illustration. Then, medyo located doon, no? So, should I say, malapit nga doon yung ating centroid ng pressure volume natin. Yan po yung natin. Ngayon, ipaproject naman natin siyang yung kanyang horizontal, no? Yung dA cosine theta naman. So, ang hinahanap naman natin this time, no, if yun ang gagamitin natin from the based on the previous illustration or slide, no, ang hinahanap naman natin ay ito naman, no, yung ating B. Sa B, ayan ito po yun. So, sabi ko kanina na horizontal projected area. Ngayon, for us to find or to calculate or to analyze yung ating vertical component ng resultant force, we will have this one. Okay? The resultant vertical force acting on the plate is equivalent to the weight of the volume of the liquid kasi po nakasubmerge. Sabihin, yung nasa taas niya, no, yung weight nun, acting above the plate or the plane or the curved surface. So, ito yung ating gagamitin this time. Ayan po, no, yung ating dA kasi, di ba, vertical siya. Ayan po yun. So, act normal. Di ba, normal force with respect to sa projected area. So, in this case, dA cosine theta yung magiging projected area with respect na nagiging normal force yung ating vertical component. Okay? Kaya dito, ito po yung nakikita natin formula for that, no? Pressure times area. Pero, dahil nga naka-incline nito, so may cosine theta, yung doon din galing yun. Okay? So, from that, no, integrate natin and we will have our integration processes. So, lalabas na yung x of V is equal to, ano po yung ating pressure? Pressure is the, what? The gamma of a certain liquid multiplied by the height. Okay? So, from our previous discussion natin, pressure variation. Okay? So, from that, no, we could say that gamma multiplied by the area multiplied by the angle of inclination is the vertical component ng ating force. Okay? Based on this one, okay, kapag meron tayo nakasubmerge. So, ayan po, no, dahil nga weight yung sinasabi dito ng ating description na weight. So, saan ba magagaling yung weight? Of course, kailangan natin ng property ng liquid, is the gamma, yung kanyang unit weight. Okay? So, ayan po yung ating formula when it comes to the vertical component ng ating force. Okay? So, to apply no, yung ating ito so, balikan na ulit natin. Ayan po yun, no, nakita natin kanina. Meron tayo F sub B. Ayan. So, weight. Sabi ko nga na weight dahil nga, since nakalubog siya, okay, yung ating surface, so malamang yung vertical component ng force na magtutulog sa kanya, di ba? Usually parang kapag nasilalim ka, di ba nga, the more na nag-dive kayo sa pool, sa dagat, di ba? Mas tumataas yung pressure. Yun yung na-discuss natin from our previous discussion. The same thing with this one. Kapag yung ating yung curve or plane, inclined plane surface, so ganun din, yung weight ng water, yung pressure niya, basically, the pressure, yung kanyang magiging force o yung vertical component na kanyang force. So, ngayon naman, ito rin yun, no? So, from that, no, balikan natin, ito siya, di ba, galing sa kaninang formula, sabi ko nga, weight. So, integrate nga natin to, so magagaling doon na kapag yung vertical component ng force natin, may kinalaman na nasa volume, okay, ito yung formula na gagamit natin, yung nasa pinakababa. Yung F sub B is equal to the integral, yung V dyan, kaya may dash line volume yun, okay? So, gamma, V sub B, bakit naging volume? Kasi yung ating dA, diba, with respect to a certain height, no, diba? Area times height is volume, okay? So, yung thickness, diba? So, ayan po yun. Ngayon, yung cosine theta, okay, so kasali yun, no, merong part yun, no, nandun na yun, in-integrate na natin, no, dun sa, kasama dun sa formula na to. Kaya, gamma, multiplied by volume, yung ating component ng ating force. Okay? So, ayan po, no, yung ating formula, no, from this F sa B is equal to P, dA cosine theta, no, we know that, yun nga, weight, ng liquid, Then, we know that for us to know the weight, no, kailangan natin ng unit weight multiplied by the certain height kung saan nakalubog. And we all know that the area of contact multiplied by the height, no, kung saan sumasakop yung area na yun, is the volume, no, ng ating component force, no, para makuha natin. Okay? So, ayan po, no, yung ating formula for the vertical component. To apply, no, so, or should I say, para ma-visualize natin, ganito po yung nangyayari sa kanya. Kaya, halimbawa ito, no, meron tayong example illustration for this one. Consider itong nakalubog na, should I say, no, na component na element, no, meron yan, no, ano itong curve na to, ayan, given yung kanya itsura, no, ito yung liquid na dito sa right side ng screen, ayan, sabi dito, F sub H will be the resultant force, pressure, rather, loading on the vertical projected area, PE, sabihin yung pag-project kasi ng ating mga forces, usually, ito nalalim sa Pascal law, diba, na kapag any direction, diba, meron kang pressure equal to itself. No? So, ayun po yun, no? Yung ating, sa point na to, yan, yung projected area na sa DE. Yan, kasi kung mahaba yan, eh. Considering na isang strip yan, di ba? So, ayun po. Then, F sub V vertical will be the force, no, or the weight of the volume of imaginary liquid. Ito daw, A, B, C, D, A. Okay, bakit may imaginary liquid yan? Sige, ituloy natin. Yan. So, dahil doon sa sa liquid na yon, no, itong imaginary na to, and A, B, C, D, A, kaya siyang imaginary para malaman natin yung component force. Paano natin malalaman? Then, let's say meron ka ditong pressure, or should I say, liquid. Ayan. So, malamang kung ito ay pataas, pababa, dito. Tama? So, ayan yung ating, kumbaga pababa dito, pataas dito. So, mangyayari doon, since mas mataas yung force na nagtutulak sa kanya pataas, kasi ito ay may liquid, di ba? So, kapag pressure, naman natin yun, no, kapag merong surface, di ba, kahit saan point sa surface na yun, no, merong pressure. Or kung ang pressure dito ay nakakontakt siya ng in normal dun sa ating surface, malamang itutulak na to ng pataas. Kaya yung vertical component natin is pataas yung direction. No? Ito, wala to, no? Wala ditong liquid component. Sabihin, wala yan. Ito lang portion na to. Yan. So, kaya, usually, ano mangyayari dito, in case of this illustration, pataas yung vertical force. Kasi tutulog na to, pataas, di ba? Parang, for example, may inarang kayo liquid or tubig, di ba? Kung nilagay nyo, di ba? Kunyari, yung pinaka-gusto, di ba? Tutulog, parang yung tinutulog na tanong pataas para makawala yung tubig because of the pressure. So, ayun po, no? Ganun ang mangyayari. Kaya ganito yung kanyang illustration. Okay? So, punta na tayo, what if, no? Kung kasi naman yung pressure natin from a gas, no? Pressure due to a gas. So, let's have this illustration. Pag sa gas, no? Actually, it's almost the same with what we have discussed earlier. Pero this time, we know that the weight of the gas is negligible. No? Hindi nga natin nakukuha yung weight ng gas. Diba? Usually, meron tayo weight ng mga incompressible liquid. Actually, incompressible liquid naman yung gas. We consider gas, no, in our subject as an incompressible one, pero usually, no, ang ginagamit natin ng incompressible liquid, no, mercury, di ba, water, oil, so ayun, no, yun natin mga ginagamit. So, ito kapag gas, pero din siya, no, the same application as liquid, no, yun nga lang, yung weight ng ating gas ay negligible. Kaya usually, ang nangyayari dito, no, yung ating mga vertical pressure, no, kung yan ay ganito yung orientation niya, no, maliliit yung value kasi na lang siya, negligible siya, di ba? So, merong value pero negligible. Okay? So, hindi siya zero agad, ha? Doon, close to zero pag sinasabi natin negligible, di ba? So, yun po, no, kapag gas yung ating mga problem. Okay? So, sabi dito, kapag pressure due to gas is uniform in all direction, no, since the weight of the gas is generally neglected. Yun nga, negligible nga. So, kaya, kahit saan point, no, the same yung pressure. Parang sa Pascal's law, kapag naglagay ka ng isang element tapos sa loob ng isang gas tank, no, yung pressure na tumatama sa element na yun, kahit anong direction, pare-parehas. No? As a result, the resultant vertical component of the resultant force of pressure acting on the flat or inclined or curved surface can be determined by multiplying the pressure, no, yung P, by its associated vertical and horizontal projected areas respectively. So, P multiplied by the area. So, the same thing yung kanina natin. Okay, but in this case, nakatandaan natin, no, in-underline ko nga, na in all direction, uniform yung kanilang pressure. Okay, kasi nga negligible yung weight ng mga gas na ina-analyze natin. Okay? So, ayan po, no, yung ating tatandaan when it comes to pressure due to gas or gases. Okay? So, ayan po, to have this application of these formulas in previous discussion natin, let's have our sample problems on this hydrostatic force ng inclined plane or kaya curved surface. Okay? So, sige, let's have this example. The seawall is in the form of a semi-parabola. Okay? Determine the force acting on the 1 meter of its length. Okay, so yung 1 meter daw, yung length. Okay? So, where does this force act on the wall? Take raw ng water as 1,050 kg per cubic meter. So, para mag-gets natin, ito yung illustration niya. Ayan. So, ayan daw, no? So, meron daw tayong wall, or should I say ito, ayan, sea wall, no? Na medyo semi-parabolic yung banda dito niya. Tapos, pinakonsider natin yung 1 meter na length, no? Parang yung thickness niyan, no? Kung 83D natin, yung 1 meter na length ng sea wall, no? Yun yung consideration. Okay? So, ang hinanap sa problem, sige, balikan natin. Sabi dito, determine yung resultant force, no? Sa resultant force, kailangan natin ng mga component forces, and we will also locate, no, yung ating resultant force na yon, no? Dito sa illustration na to, kung saan dyan tatama yung resultant force natin. Okay? So, with our solution, yan, so, paano pagkakan natin yung weight ng A, or should I say, yung weight kung saan from doon sa ating top ng ating surface, papunta sa pinakababa ng wall, gagamit itong formula to, rho G H L, or, di ba, kapag wala kasing gamma, no, kapag rho yung binigay, no, ayan, kapag mass density, rho G, okay? So, meron na tayo nung rho ng water, binigay kanina 1,050 kg per cubic meter. Yung G, okay, alam natin yan, 9.81 meters per second square, multiplied by the height, no, kanina nakita natin 8 meters yung height, yung ating retaining wall, yung ating sea wall, no, then yung L, yung length na ina-analyze natin, which is 1 meter, okay? So, yung ating WA, no, or should I say, yung force, or yung pressure na nag-act sa ating retaining wall at a certain 1 meter length, okay, is 82,404 Newton per meter, or 82.4 kilonewton per meter. Okay, so dahil alam na natin 82.4 kilonewton per meter siya, ayan, so ito yon, di ba? So, ito yung na-compute natin, no? Ito yung sinasabi ko, di ba, na ito yung pressure na yon, considering a 1 meter length, no? Ayan, yung nakita natin kanina, binanggit kanina sa problem. Ngayon, kailangan natin malocate, or should I say, kailangan natin malaman, ito na, yung component forces. Yung ating F sub Y, tsaka F sub X, dahil kailangan natin yun to have yung ating resultant force. Okay? So, to compute for the component forces, yan, so, i-retain natin yung station kanina. Yan, so, for our horizontal force, yung ating horizontal force, ito yon. So, gagamit tayo, di ba, ito kung mababasin nyo, naalala din mo sa inyong statics of rigid bodies or engineering mechanics, no? Para kapag triangular ang loading, so that is, kung ano yung formula natin doon sa triangle, okay? That's one of these side. Kasi, di ba nagpa-project doon sa area, napansin nyo kayo sa previous discussion natin, ito yun. So, kaya 1/2 multiplied by 8 yung height, multiplied by itong pressure na to. Okay? 82.4 kilonewton per meter. So, yung sagot natin dyan will be 329.62 kilonewton. That is the horizontal component or horizontal force component. Okay? So, para yung location, yung sa location naman niya, so let's say na manggagaling siya dito sa taas, no? Kasi ito yung ating di ba? Parang basis kasi dito sa taas nanggagaling, di ba? From 0. Okay? So, mula dito sa taas na to, it will be 2/3, no? 2/3 kapag triangular loading. Okay? So, 2/3 multiplied by the height, which is 8 meters. Ayan. So, yung ating horizontal na force, no? Will be located from the top, no? Yung Y bar natin, or Y, as 5.33 meters mula dito sa taas. Okay? So, ayun yung ito yung ating horizontal component with its location from the top. Okay? So, since meron na tayo yan, Okay? So, alamin naman natin ngayon yung kanyang vertical component. So, vertical component, ayan, so, relative to dito yung illustration ulit. So, ayan, sa vertical component, okay, so, kailangan, ang formula dito is rho g multiplied by the area. So, kung sino kayo, di ba? Gamit natin yun, gamma, ano yun? Uh, gamma volume, di ba? So, yung volume, ito yung gamma, di ba? Rho g. Volume is area multiplied by height or length. Okay? So, ating length 1 meter binanggit sa problem. Area ng ABC, ito yan. ABC, no? Since ito is parabolic, so, almost parabol lang nga. Diba? Kasi nanggaling sa kanyang parabolic form. So, kung galing sa parabola to, okay, yung area niyan is yung area, no, kapag yung ginagamit niyo sa inyong previous subject is engineering mechanics. Okay? So, sige, apply natin yon. Kapag area ng parang semi-parabolic or spandrel, okay, ito yan. Rho G, rho is 1,050 multiplied by G, 9.81 meters per second squared. Okay? Ayan yun. So, multiplied by natin, ng previous itong spandrel na to, napapansin nyo, is 1/3 multiplied by base times height. Itong 1/3 na to, galing to dun sa formula na kapag area ng spandrel is 1 over n plus 1 multiplied by base times height. Ano yung N? N is the degree ng ating spandrel. O itong parabola na to. Kapag parabola, ano yan? Yung N natin is 2. Diba? So, kung parabola, kung ang N is 2, ayan yun. So, 1 over 2 plus 1. Kaya, 1/3. Okay? 1/3 multiplied by 2 times 8 kasi ito yung ano niya. Okay? Base. Ito yung base, diba? 2. Parang pinaliktad natin. Okay? Nirotate times height, which is 8 meters, multiplied by yung length, no, na ina-analyze natin, 1 meter. Okay? So, sagot dyan, no, for our vertical component will be 54.94 kilonewton. Ayan po yung sagot natin for the vertical component ng force. Ito po. Okay? So, para naman sa location niya, ito, X bar. So, magpalagay natin, galing po siya dito sa straight na to, no? Dito sa side na to. So, that is ayan. So, para sa vertical component, no, 3/4 ng, 2 meters. Okay? Kasi nga, kapag sa spandrel, okay, so, ang ating location ng x component with respect to this one, no, dito sa point na to, galing sa kanyang, kumbaga 0, no, is 3/4 multiplied by base. Or depende kung ano yung tawag dito sa location to, H or B, depende. Okay? Pero siya ay 3/4. Okay? 3/4 multiplied by the base, which is 2 meters. So, ating x value will be, ayan po, 1.5 meters. So, 1.5 meters mula dito sa location. Ayan. Okay? So, since alam na natin yung ating component, no, meron na tayo, let's have with the resultant force. Sa resultant force, the usual resultant force, no, since from your engineering mechanics, no, statics and strength of materials, or mechanics of the formable bodies, no, the resultant force equal to the square root ng mga sum of the squares ng mga component forces. So, ayun yung square root ng f of x squared plus f of y squared. So, substitute dun sa formula. So, that is square root ng 329.62 squared plus 54.94 squared will give us the value of 334.17 kilonewton. Okay, yun yung ating sagot for that. Okay? So, ayan po. Ito. Ayan. So, that is our answer for this problem. Okay? Ito yung ating hinahanap, yung resultant force. Yung location, ayan. So, na-solve natin kanina. Okay? Sabihin, banda dito yan, no? Kung i-project natin hanggang dito. Dito, papalagay natin nandito nga yan. Okay? Nandito yung ating resultant force. Okay? So, hindi naman hinahanap yung angle of inclination ng force, pero if needed, so, i-solve nyo. Okay? Depende kung saan ba with respect to x-axis ba or to y-axis. Okay? So, depende kung in-state sa problem. Kung hindi naman, kung resultant force lang, edi resultant force lang or yung magnitude lang yung hinahanap. Okay? Wala na direction. Okay? Sige. So, ayan po yung ating answer for problem number 1. Okay? Sige. So, to further apply no, yung ating formulas, no, or ating discussion today, let's have this problem, second problem, okay? The semicircular plate is 4 feet long and acts as a gate in a channel. So meron daw tayong semicircular plate na 4 feet. This time, kanina, 1 meter yung length. No? So this time, 4 feet naman ina-analyze natin. And acts as a gate in a channel. Determine the resultant force the water pressure exerts on the plate and then find the components of the reaction at the hinge. Smooth support or yung roller support natin, di ba? Neglect the weight of the plate. So, para ma-visualize natin yung problem, ito yung kanya illustration. So, ito tayo natin, ito yung gate na naka-curve. Ayan. So, sabi, even yung kanyang diameter, I should say radius 3 feet. So, therefore, yung diameter niya, 6 feet, di ba? Yan is atin 4 feet long. So, kung yung kanyang, kung naka, ano to, tayo ito, isometric view, no, meron siyang 4 feet doon, no? Analyze natin. Okay? So, hinahanap, resultant force, tapos hinahanap din, no? Yung force dito sa smooth support, sabihin yung roller niyan, value niyan, and also yung ating hinge support, B. Diba? So, gate to, ibig sabihin, pwedeng mabuksan talaga yan, no? Parang ito kasi hinge, ito naka-roller. So, parang nabubuksan-buksan yung gate, no? Para makapagpasok yung tubig. Okay? So, to answer, or should I say to have the solution, ayan, sige. Ito yan. So, ganito yung ating solution for that. Ito yung illustration natin, pero para ma-visualize natin, or should I say, may natin illustration na yan, sagutin natin ngayon yung problem. Okay? So, bakit nag-resort sa ganito? So, bago yun, let's take na yung gamma ng water since hindi binigay, no? Palagi natin, just like yung mga usual na values na meron tayo na given na, just like yung 9.81, the G, diba kapag rho, no, kapag sinabi 1,000 kg per cubic meter, alam yung kanina kasi binanggit, okay? Pero this time, since hindi binanggit yung gamma ng water, since meron tayo kailangan sa problem, no, gamitin natin yung 62.4 pounds per cubic foot. Okay? So, ayan po, no, yung gamma ng water na gamitin. Okay? Para mag-compute natin itong WB. Ano yung WB na ito? Parang kanina, no, kailangan natin yun to solve yung ating mga forces. Specifically, yung ating horizontal force. Ang formula din is gamma ng water multiplied by HB. Ano to HB na to? Yung height. Okay? Ito yan, yung height na yan. So, ano yung nabanggit? Ito yung kanina. Since 3 feet yung radius natin, 6 feet yan. Okay? And the B, ito yung length. Okay? So, ito po yun. No? Ayan yung ating length na ina-analyze. Yung 4 feet. Okay? Then, substitute na natin. Okay? That is 62.4. Ito yan. Multiplied by 6. Ito yun. Okay? Kasi nga, 3 feet yung nakalagay ito na radius. So, kung diameter niya, kasi semicircular to based on the problem, that is 6 multiplied by 4 feet. So, running that equation, so we will have the WB is equal to 1497.6 pound per foot. Okay, yun yung ating triangular pressure, no, on this one. Okay, na nag-act ito sa gate. Okay? Actually, no, para hindi kayo malito, no, just like yung kanina, usually, di ba, nabanggit natin, kapag mga pressure, it will always act normal dun sa surface. Kaya, yung ating force, laging, di ba, pansin nyo, nakaka-curve, pero bakit ganito yung itsura? Kasi nga, acting normal sa contact surface. Kumbaga, ang analysis, normal force or normal pressure. Okay? So, applicable din yan kasi nga, di ba, may tinatawag tayo sa engineering mechanics na transmissibility of a force. Diba? So, kung nandito yan, magkakaroon ka dito ng line of action, so dito matama din yan dito sa linya na to kung may gagawa ka dyan ng line of action ating force. Okay? So, ayun din yan. The same lang yung concept na yun kasi ito po ay fluid mechanics. So, the same thing, no? Engineering mechanics. Okay? So, ayan po, no? Yung ating pressure. Ngayon, para ma-compute na natin, no, yung components, kasi hahanapin natin yung resultant force. To have the resultant force, let's resolve muna yung mga component forces. Okay? So, first, we have the ating horizontal component. So, horizontal component, no? So, just like yung kanina, since triangular loading ito, 1/2 base times height. Ano yung base? Base is the H sub B, yung ating, or should I say yung WB, yung pressure nandito. Then, yung ating H sub B, ayan. So, yung height, or yung in this case, yung diameter ng semicircular. Okay? So, 1/2 WB multiplied by H sub B. So, substitute, 1/2 multiplied by 1497.6 multiplied by 6. Yung sagot dito ay naka-divide na sa 1,000. It will be 4.493 kips or kilopounds. No? Yun yung kip. Then, for the location, yung H, nakikita nyo dyan, okay, eto. So, let's say, na manggagaling naman dito, halimbawa, dito naman, kasi either way, di ba, pwedeng 2/3 mula dito, pwede naman din galing dito. So, okay lang, no? Wala namang problema. Kasi known naman yung distance na to. Okay, alam naman natin. So, let's say, galing dito sa hinge support, no, sa point B, that is 1/3 nitong 6. Okay? So, therefore, yung ating sagot is 2 feet, no, mula dito, sa hinge. So, bakit kailangan natin to? No, aside from the fact na kailangan natin siya for the location of our resultant force, though hindi naman sinasabi na kailangan ng location, kailangan natin to mamaya to compute for the forces na nag-act dito sa hinge na point B and smooth pin, or should I say smooth roller, smooth support or roller A. Okay? So, ayan yun. No? So, H natin is 2 feet from dito sa point B na. Okay? So, ayan po yung ating component or yung horizontal component. Now, let's have yung ating vertical component. Ito, yung F sub Y. Bakit kaya napunta dito? Sige, let's have this one. Okay, palakihin natin yung illustration. So, since ito na-complete na natin, F sub X, alam na rin natin to. Okay? So, ito F sub Y, ito yung force na kailangan natin. No, pinalang na kayo sa unang illustration, yung naka-incline na nakalubog din, no, na meron doon sa una na pinakita ko sa inyo, yung imaginary na volume or force, or volume rather. So, ganun din yung ano nito, yung application dito. Sige, tignan natin yan. Paano kaya nag-resolve sa dito? Ito yung pinanggalingan yan, okay? Let's say na yung portion kanina, okay, ito, balik natin ha. Ito. Itong portion na to, ayan, ito, yan, hanggang dito. Meron tayong tinatawag na force na pataas, upward force. Okay? Imaginary upward force. Okay? So, anong gagaling doon? Ayan. So, ito yon. Okay? So, ngayon, yung kanina na iwan, ito yun, no? Yung ACB. Yan. So, ito yung naiwan, ACB. So, alam natin na, di ba, from the concept kanina ng vertical component, weight ng liquid, tama? So, since weight ng liquid to, pababa yung direction. Ngayon, kung titignan natin, mukhang kapag mathematically speaking, pinag-combine natin siya, ano mangyayari? Magiging, matatapyas itong portion na to. So, malamang sa hindi, yan ay magiging semicircular. Pero yung sagot ng mga forces o yung direction, ang governing direction ay pataas. Okay? Base dito sa illustration, kasi kung ito, may imaginary liquid siya na inassume, no? Parang inassume yung imaginary yan. So, magiging pataas yung vertical force na nag-a-act pag pinagsama tong dalawa. Okay? Kaya siya ganito. Okay? Kaya ganito yung kanyang orientation. Okay? So, yun yun. The same thing yung kanina na pinakita ko sa inyo. Parang gano'n, no? Magkakaroon ka ng imaginary area on this one in relation to this kasi ito yung ina-analyze natin, di ba? Okay, so ito kasi alam natin ito pababa di ba? So wala na to. Kasi pababa Di ba? Magiging pababa yan. So alam natin na hindi na yung mag-act dito. No, pababa kasi, vertical. So, yung ito na lang, itong portion na to. Ngayon, ina-analyze natin siya na kunyari, merong certain liquid, no, or should I say parang unknown, no, or liquid na kasama tong area na to, kaya nag-resolve sa ganito, yung A, B, C, D, no, na area na may liquid, halimbawa. No, so, pag mathematical pinagsama yan, so, magiging semicircular ulit, tapos yung governing direction, pataas. Okay? So, kaya yung ating vertical component force ay pataas siya, ganito. Okay, so, yun yun, no, yung pinagganito. So, to calculate for the vertical component, yan, so, repeat natin itong illustration na to. So, yung solution natin is gamma ng water, alam nyo kasi kailangan natin ng liquid, no? So, water yung ina-analyze naman natin. So, gamma ng water multiplied by the area ng ACB, ano yun? Yung ACB, which is semicircular, okay? Multiplied by B. So, ayan yun, no? So, 62.4 multiplied by 1/2 yung area na pi r squared kasi kalahati, di ba? Alam natin yung r na 3 feet kanina, multiply by b, yung b na yan yung length, no? Yung ina-analyze natin, 4 feet. So, running that equation, we will have 3.529 kips or kilopounds. Okay? Itong sagot na to, dinipid na automatic sa 1,000 kaya naging 3. So for that location, sabihin, pataas nga to. Ayan. For the location, mula dito, no, pag semicircular, okay, hindi natin analyze na, kasi alam naman natin mapupunta sa bandang gitna yan, di ba? Semicircular yan. So, sa kanyang, tawag dito, sa kanyang distance, yung D, no, para sa kanyang location, no, so kung nalalink nyo sa statics or engineering mechanics, no, the location of that will be 4R over 3 pi. Okay, substitute natin, no, 4 multiplied by 6 over 3 pi. So that is 1.273 feet. Ayan yung ating location para dun sa vertical component. Since meron na tayong horizontal component, meron na tayong vertical component, let's answer yung isang problem o yung isa dun sa hinahanap, which is the resultant. So yung resultant force natin, so the same, no, kapag tayo nagkakapit resultant force, square root ng sum of the squares ng ating mga component forces. So, F sub R resultant force equal to square root ng 4.493 keeps squared plus 3.529 keeps na naka-squared. So, therefore, yung value natin is, na resultant force is 5.71 kip. Okay, yun yung sagot natin for the resultant force, or 5.71 kilopounds. Okay, yun ang una sa hinahanap natin sa problem na to. Okay? So, yung kanyang location, wala, since the time said, kung nabanggit na kailangan ng direction, kukumpute natin yung angle of inclination niya with respect doon sa ating mga component forces. Okay, kasi doon manggagaling yun, di ba? Pero since hindi naman, okay, so wala. So malamang, no, this the transmissibility of a force, so kapag naglagay ka dito ng line, projected line, papunta dito, ayan. So nakita yung ating resultant force. Ayan. Okay. So ayan yun, no? So, yan yung sagot natin for resultant force. Now, next natin hanapin ngayon, yung mga component forces ng mga supports, no? Dito sa B hinge, dito ay roller sa point A. So, balikan natin. Ayan, so ito, may illustration na. Ayan yung 4.493. May given na distance. Sabi ko nga, kailangan natin to for computation natin ng mga component forces. We also have yung 3.529 na may distance na 1.273 galing dito sa line of action na to. Ayan. So, meron tayong 6 feet na given kasi 3 feet, diba, yung radius. So, alam na natin ngayon, yung component force dito sa A, isa lang naman kasi roller to, pero sa B, dalawa kasi hinge. Okay? So, to compute, ayan. So, mula dito, computing muna natin, no? Mag-sum tayo ng forces sa along Y direction. Kasi mako-compute na natin agad yung B sub Y. Okay? So, 0 is equal to Fy pataas, no? Yung ating ito. Pagpataas positive, pagpababa negative. Okay? So, minus B sub Y. So, 0 is equal to 3.529 minus B sub Y. Therefore, B sub Y is 3.529. Keep, no? Yun po yung ating sagot for that. Okay? So, ayan po, no? Yung ating component force para sa, yung kasama sa point B. Okay? Now, mag-sum naman tayo ng moment. Okay? Mag-sum naman tayo ng moment sa point B. Okay? So, gagamit natin notation. Kapag counterclockwise, negative. Kapag clockwise, positive. Okay? So, ito po yun, no? So, 0. Ayan. Mag-sum tayo, no? Dito. 0 is equal to, negative, no? Kasi nga, ito ay magiging, mula dito pa, nag-sum ka, no? Counterclockwise yan. Okay? So, so, negative yung ating direction. Or should I say yung ating notation dyan. Kasi plus, itong 4.493 kasi, mula dito magiging clockwise, no? Kaya positive. Multiply by moment arm niya na 2. Okay? So, substitute tayo, that is negative F sub A. Yan yung hinahanap natin, no? Multiply by 6 plus 4.493 multiplied by 2. Therefore, yung ating F sub A is 2.246 kip or kilopounds. Okay? Kasi kilopounds naman yung ginamit natin yun. Okay? So, ayan na yung okay na to sa A natin. Okay? Ngayon naman, wala na lang ito. Okay, para ma-compute to, meron tayong two ways to compute for this one. One, magtasum ka ng moment sa point A. Or, para mas madali, since sure ka naman, or kung sure ka na tama yung na-compute mo dito, sa F sub A mo, okay, mag-sum ka na lang ng forces along horizontal. Okay? So, para sa force no, horizontal forces, yun nga, pag rightward, positive. Pag leftward, negative. Okay? So, 0 is equal to negative f sub a kasi leftward to, plus f sub x, ito, yung component, minus, kasi pa leftward siya, b sub x. Okay? So, ayun yun. 0 is equal to negative 2.246 plus 4.493 minus b sub x. Okay? So, running that equation, b sub x equals to 2.25 kip. Okay? Yan po yung sagot natin for the horizontal component ng force na nasa hinge sa point B. Okay? So, doon po nagtatapos yung ating discussion, no, when it comes to our uh, hydrostatic forces on the inclined plane and or kaya curved surface just like this one. Okay? If you have any questions or meron kang concerns, you could comment down dun sa comment section, or if you're my student, no, sa subject na to, you could message sa group, no, to ask or clarify things regarding this discussion. Okay? So, keep safe, class, or for those who are watching this video, mag-ingat pa din, and have a great day. Hopefully, you've learned something about this on fluid mechanics. Okay? Thank you, and God bless you.